Hi everyone, welcome back to Loga QA Automation channel, and in today's video we are going to cover Python inheritance. First of all, we'll see what is inheritance, and then we'll see what are the different types of inheritance available in Python, and then how can we practically use them in our automation framework. So this is what we are going to cover. Without any delay, let me directly jump to the PyCharm. Okay, so this is our project where we have covered so many other topics in Python. So today let's go with the same folder, OOP basics, and here I would create a new Python file. Let me give the name as test8. Alright, so first I'll explain you why we need inheritance, right? For that I'll give you a practical example. Say you need to have a class, okay? Class student. Okay, when I say class student, I want to create some variables, okay? Name, and then say ID, and then I would say section, right? These are the class level variables I'm creating. Just for your understanding, I can create instance variables, but for now I would go with class level variables, okay? And then I'm creating another class called, say, faculty. Okay, so here again I'm going to say name, because the people who work for an organization will also have the same properties, right? Data members, again they will have ID, but they will have department, they don't have section, correct? And then let me create, say, class driver. Say the organization has the bus, maybe a school bus or a college bus, for which they have drivers, so they will also have name, and then they'll also have ID, and then they'll have, say, the route number, right, to which they are appointed. Now you see that I have created 3 classes, but something is in common. What are they? Name and ID, they are common across these 3 classes. In that case, do I need to repeat them? Not required. So how can I avoid it? I can create one common class, right? I can create one common class called person, and here I can have name and ID, and then what I can do, I can take these 2 in my next classes that I'm creating, or I'm going to copy these members from this class to my other classes. So class student, okay? For example, I'm saying I am not showing it how I am doing it. I want this name and ID, then I would say person here, and then I would just say section equal to this, then class, say, faculty, then again person, and then here I will say department equal to, and then I can say class drivers, and I can say route number. So first person and then route number. So what are we understanding from here? First thing, I'm going to have better reusability, right? I'm not repeating this name and ID in every class that I'm creating. Instead, I'm going to keep it in my base class. I can call this as base class, or I can call this as super class, because these are going to use the super class, right? So I can call this as super class, or I can call this as parent class. So whatever way you feel convenient, you can call it. So this can be a base class, this can be a super class, this can be a parent class. All these are child class, right? This is parent class, these are child classes, which is they are going to use the base class, and by doing that it is going to give us the reusability. So that is the advantage of having the inheritance. So far I was saying copying, right? Instead of copying, I can say these child classes are inheriting the properties of the parent class. So because name and ID are data members, are properties of person class, right? I'm reusing those in the other classes. So this is what is called as inheritance. Inheritance is nothing but the way the properties are reused by the child class by inheriting the parent class. That is what is called inheritance. Okay, let us programmatically see how we are going to achieve this. Say I have a class A, and this class has a variable I is equal to 10. Now I am going to create another class B, and here I have a variable J equal to 10. Now using class B, I can print, right? So say print B dot J. What is going to be printed? It is going to print J. Let me select the current file and then run it again. Right, this is the J value 10. Let me increase it to 20 so that it will be better. So now you can see 20 is getting printed. So here I am not creating any object because this is a class variable. To access the class variable, I just need the class name. So class name dot the variable, it prints the value of the class variable of B. Okay, now I want this A. How can I do it? So now I want the I value. How can I do it? Print A dot I. If I do this, I can get it. So this you already know how to get the values of class variables using the class name. Now I'm going to do a small change here. I'm going to say class B of, and then here I'm going to put the class A. So what this line means is class B inherits class A. Okay, so now this is B dot I, correct? So I'll say print, right, or I can go with this star 10. Hope you remember this, otherwise you can refer the previous class videos to understand what this means. It is going to print the dash for 10 times. Alright, so now here I'll say print B of, that is B dot I, and I'll run this. So you can see that using class A's name, I'm accessing the variable I, A dot I. Yes, it is printed. Next, what I'm doing, using class B's name, I'm accessing the variable I, which is not there in this class, but it is there in the parent class of B or super class of B, right? B is inheriting A and it is acquiring the properties of A. That's why even with the class name B, I'm able to access the variable I, which is present inside the class A. So that's why it is printing 10. And then the regular one, right? This J is already there in class B. So this is also I'm printing B dot J, it is printing. So now you understand how are we going to inherit and use the properties. So you may ask a question, the inheritance will be applicable only for class level variables? No, it is applicable for class level variables, class level methods, and then instance variables, instance method too, even for the constructors. Okay, we will go to them one by one, step by step. But first understand what is inheritance and how can we achieve inheritance is what you have seen. This is the syntax for achieving the inheritance, B of A. Now let's go to the different types of inheritance we have in Python. First type is single inheritance. There is a child class B which inherits the property from A. This is what we have seen here. There are only two classes, and the second class is inheriting the properties from child class. The next inheritance is multi-level inheritance. We'll go and see it. So first is A. This is not inheriting anything. B is inheriting A and then C is inheriting B. Let's do this. Okay, class C is inheriting what? B. And then here I will say ij k, k is equal to say 30. Now what am I going to do? Using the class name C, I'm going to access I, j and k, all three variables, but C has only the variable k, it doesn't have I and j. Just because C is inheriting B, first j is getting into it, but in turn B is inheriting A, so due to which it is like a chain, all variables from the super classes are getting inherited and we can access it through the class name C. Alright, so let me accept this. Right, now I'll run this. You can see that 10, 10, 20 and then 10, 20, 30. So this is called multi-level inheritance. Right, there are different levels. You understand, like say multi-level car parking, right? So you will go level 1, 2, level 3, level 4 to park your car. So this is what is called multi-level inheritance. Next is hierarchical inheritance. What is hierarchical inheritance? Now I have class B, class C, but class B is inheriting A, class C is inheriting B. Instead of this, I am going to inherit A, right? So B is also a child of A and C is also a child of A. That is what, okay, they have this diagram has a different way, then I would represent it in that manner. The C is the base class, so I'll change it to C here. C is the base class, then A and then B, and what am I going to do? A is inheriting C and then B is also inheriting C. Okay, so C has I, A has J, B has K. Now you guess what is going to happen. Okay, so first, what are the different ways to access I? 1. Print C dot I. Next, print A dot I is also possible because A is inheriting C, correct? A dot I. And then print B dot I. That is also possible because B is also inheriting C. Let us run this and check. Correct. So I is printed. Next, just for your clarity, okay, when it is printing, I would like to give a small clarity here. Okay. Okay, let's run this again. You see that the I value is printed. So these are the three ways in which we can call I. Next, print, I would say star 10. Okay, next, if I want to access J, what are the ways I can access J? Print J, comma, J is in class A, so I can do A dot J. But is A being inherited by any other classes? I don't see it, right? A is not inherited by any other class, so I cannot access J by another class name. I can give it a try just to prove my point. Print J, say I would try C dot, because C is the parent class, right? Let us see what is going to happen. C should be a capital letter. Good. And then yeah, it is suggesting me no, it is not suggesting me that. Okay, let me see, okay, how it is going to run. Let us run it. Okay, so J is printed. Let me reject. J is printed for the call A of J, that is A dot J, but for the C dot J, it is saying attribute error. This attribute is not there in the class C. That's why you're getting this attribute error. Understood? And very similar to it, if I want to access K, there is only one way, that is using the class name B. So let me change it then. Okay, CK, and then I have to use the class name B, and then I have to use the variable K. All right, it is printed. So for accessing I, there are three ways, but accessing J and K, there is only one way. But from this, what are we understanding? Hierarchical inheritance is possible in Python. What is meant by hierarchical inheritance? One class can be inherited by multiple classes. It is not that always one class should be inherited by another class, right? Only one class can inherit another class. No. One base class can be inherited by multiple classes. Understand like this. Say one parent has multiple child, right? So if there are multiple children, then every child will inherit the properties of parent, right? That is how you need to understand. Next is the very, very important one, multiple inheritance. People who know Java can immediately raise the point that this is not possible in Java. Is it really possible in Python? Yes, the answer is yes. Multiple inheritance is possible in Python, right? Let us see what is multiple inheritance. So let me go by the image itself. So class A, let me have class B, and then let me have class C. So I have three classes now. In this, A and B are parent class. So B should not have any inheritance. So A doesn't have inheritance, B doesn't have any inheritance. Now C is inheriting A and B. So simple, right? A comma B. The moment I put comma, it means it is going to inherit one more class. It is not just two class, right? If I have another class, I can put comma another class name. So one class can inherit multiple classes. That is what is multiple inheritance. This is not multi-level inheritance. Understand this or remember this. Multiple inheritance. This is not possible in Java. There is a reason. When I'm taking the overriding polymorphism thing, I'll explain it a little clearer why multiple inheritance is possible in Python and why it is not possible in Java. But for now, you remember, in Python, multiple inheritance is possible. Okay. All right. Now, let me print I. What are the different ways to print I? Print A dot I. This is possible. And also print C dot I. These two are possible, right? Right. 10, 10. Now, I want to print the value of J. What are the possible ways? Print star 10. Print B dot J. And another way is print C dot J. Is there any mistake that we are doing? No, we are not doing any mistake. Okay, good. So 10 is printed twice, 20 is printed twice. And how are we printing? Using the child class C's name, right? So this is multiple inheritance. The last is nothing but combination of two or more types of inheritance. So here, what is the combination? So first is single inheritance is here, and then single inheritance is combined with this multiple inheritance, right? BC is inherited by D. So B and C, multiple inheritance is this level, and here you can see this is single inheritance, and these two are combined. So this is called hybrid inheritance. I would like to quickly give an example. A is not inheriting anything, but B is inheriting A. In that case, I have to put B of A, and then I'll create C. C is also not inheriting anything. C is also a parent class. I'll name it as C. I'll give the K is equal to 30. Cool. Then there is D, and this D is inheriting B and C. So let me put B and C. ijk, and then this will be L, and I put value 40. All right. So A, B, C, D. In this, A is a parent class. It is not inheriting anything. B is a child class of A, and it is inheriting A. C is a parent class. It is not inheriting anything. This has a variable k is equal to 30. Class D has inherited two classes. One is B and then another one is C. Right? These two it is inheriting. Here you need to notice this B is inheriting class A. Right? So A, B, D. Right? A, B, D. That is the path it is taking. A, B, D, and then C to D. Okay. All right. Now let us see what are the ways in which we can print I. So I can be printed by A, class name A, using class name A, also by B, and also by D, because B is getting inherited here. Let's check A, and then I'm going to put B, and then I'm going to put D. I'll take this off, it's not needed. Okay, let me run this. Cool. So A, B, D, right? In all three, I'm printing the value I, the variable I. Next, let's see J. J can be printed by the class name B and then class name D, right? Because B is inherited in D. Print B dot J is possible. Also print D dot J is possible. Let us run it and see. Correct, that is also working. And then let's see K. So K is in class C. So C dot K is possible, and also D dot K is possible. Print C dot K, then print D dot K. Let me run this. Yes, 30 is printed, and finally we need to print 40, and one and only way to print 40 is using this class D. Print D dot K. See it? Why is it 30? Okay, it should be D dot L. Right, it's printing 40. All right, clear? We have covered the different types of inheritance in Python. We first understood what is the reason we go for inheritance, and then we covered different types of inheritance using class variables. Next, I'll explain you using the class methods and instance methods and instance variable. Okay, so it will be easily understandable for everyone. Okay, so for this I'll create a new file, type 8, 9. Okay, let's test 9. So we have test 9 now. Let's go with class A, and we'll, so we all know that how to create you guys know, right? What is this underscore underscore in it? Just give me a second, let me have some water. Yeah, I'm back, guys. Okay, so what we are creating here is we are creating a class A, and then we are creating a constructor, right? So this constructor has to variables I and j, and the moment the constructor has variables, those are called instance variables, right? Right, now what I do, I'll first say this is a function, right? So only then, yeah. In Python, how do we put variables inside the constructor? Using the keyword self, right? Yep, that is what we have done here. Nice. So first we created a class A, and then inside the class A we have a constructor in it. It takes, constructor takes the self as an argument, and then self of j comma self I and j are 10 and 20. Now I'll create another class called B, and then here also I have a constructor. Let me go with one variable first to make you understand. Okay, 20. Okay. So we all know how to access instance variable. How can we access? Say obj a is equal to a of, right? And then obj b is equal to b of. And then if I want to access the variable I, then obj a dot I, print obj a dot I, let's see, and then print obj b dot j. Let me run this. 10 and 20 are printed. So this we already know how to create a class, how can we create a constructor in it, and then inside the constructor how can we define the instance variables, define and initiate the instance variables, and how can we access those instance variables using objects we know. Now we are going to bring in the inheritance concept here. So class B is inheriting class A, and after it inheritance class, after B inherits class A, we'll do the same. Okay, so class object A, object B, I'm printing obj a dot I and obj b dot j. Will it work? It's working perfectly. But after inheriting, why do I need to have a object again, right? A object again for class A. Why can't I use object of class B and access the instance variable of class A, right? That question will naturally come. How can we do it? So print obj b dot I. This is what I'm expecting, right? Obj b dot I and then obj b dot j. Let's see. It's giving me an error. It says attribute error. B object has no attribute I. Okay. In so far what we understand is the moment we inherit, all the properties will be copied to the inherited class, right? That's what we understand. But now why is it not copying? Actually it is copying, but the problem is here the method init is here copied, but there is one more time method init is created. So in Python, if we have two methods with the same name, what I mean, let me explain. Say def add is adding c is equal to 1 plus 2. Def add c is equal to 3 plus 4. Now what will happen if I call add? print C. I'll comment this all. So in Python, what will happen when I call add C? It prints 7. So that is 3 plus 4, 7 is printed. Why is it not calling this 1 plus 2, 3? Because this add has overwritten, right? Understand, it is not overriding, okay? It is overwritten the existing method. So that's why in Python we cannot have another method with the same name in the same scope. If we have it, then it will be overwritten. And the same problem is happening here too. Observe carefully. So here there is a constructor underscore underscore in itself, and B2 had this underscore underscore in it. That's when I say obj b.i, there is no b.i. Let me cancel this. There is no, because this has overwritten the existing one, so there is no I, right? It has overwritten the A class constructor, so there is no I. That is the reason when I try to access it using objb, it is not happening. So the simplest way to solve this is, you can use the class name A dot I is equal to right. So what I'm doing is A dot underscore underscore init underscore underscore this. Okay. So here what I'm doing, I'm calling this constructor class of A here, right? Let me see now whether it is working or not. Again, it is not working. Why is it not working? Because we need to pass self. Yeah, now it is working. See? So when I use the class name dot the constructor name, I have to pass self. So far we have seen multiple methods where self is the first argument, but we have never passed self as an argument when we call them, right? It will be taken automatically, but only during the inheritance. If you are using the class name to call the constructor of that class, then you have to use the keyword self as an argument. Remember this. If you want to avoid this, the easiest way is super keyword. So super of dot underscore underscore init, right? I will comment this. Now I'm not passing self here, but if I run this program, it runs properly. It prints I one more time 10. So this 10 is coming from obj b. So, but obj b doesn't have the variable I, but still it prints how? It is taking the parent class's constructor, and from there it is taking the value because of this super of dot underscore underscore int underscore underscore function. But here we are not passing self. If we don't want to use super, then we can go with the natural way. By using the class name we can call it, but only thing is you need to pass the self explicitly. It will not take automatically. Remember this. All right, now I have the super. What does it mean? Super class of B, right? What if the class B is inheriting two classes? I'll name this as A1, okay, and I'll put another class as A2, and then here I'll say A1 comma A2. Okay, so class B is inheriting A1 and A2, and here I'm saying this is I in both the classes. Let's say it is I only. Okay, so I keep one as 10, another one as 100. From here, when I say super, which class will it refer? It will go to A1 or it will go to A2? Any guess? What I ask is, when I create an object for this B, and after creating the object, if I try to print I and j, will it take the value of I from A1 or A2? Let me run it. Okay, yeah, it's not. We don't need this anymore. We don't need this anymore. For this example, this is good enough, right? So this is taking the value of A1, right? Because it is printing 10. Let me increase it to 100, and here I'll decrease it to 10 and show you. This is printing 100. It is taking, the super is always taking the first parent class value in the order, right? That is when the super comes into play. Okay, to avoid this confusion, just to show you, right, I'll change it to A2 here, and then I'll put A1 here. Okay, now it will print 10 because A2 has the value I 10. See, now it prints 10. Just by changing the order in which the inheritance is happening, I can control which variable the super should refer, right? Which class the super should refer. All right, now let me go back to A1 and A2, and then to avoid all this confusion, whenever there are multiple inheritance, better to use the class name instead of the super, because it is going to create confusion. You need to know the order and all, right? So now it is simple. A1 dot init, and then A2 dot init, and then self. Now you know, right? So now you know that the moment A2 dot init kicks in, this overrides, right? Because they both have I. So let's see, it has 10, 20. But if I go with this, in this order, what is going to happen? It is going to print 100. Got it? All right. So this I just wanted to show you the use of super keyword, and then how the order matters when we do inheritance. And also the one more thing, I can again go with super, right? Super dot underscore underscore init, and this time what happens? It is again going to take the leftmost one, right? So let me go like this. First I'll put A1 in the order, and then A2, and then super. So what is happening? First it prints A1's I value. A1's I value is 100. Then A2's I value is 10. But finally, when it calls super, it looks for the first parent class, and then it takes the value from there. So again, it becomes 100. The I value finally in this class becomes 100. So when I print it, 100 gets printed. One more thing that you notice is the super of keyword can come in any place under this constructor. If you compare this with Java, Java is a bit strict, and you cannot have the super keyword other than the first line in your constructor, the child class constructor. But here there is no such restriction. In Python, you can keep the super keyword at any place in your constructor, in any line of code in your constructor. Okay, got it? All right. So this is an example of using the instance variables in inheritance. But now let's see how to use the methods, right? So let me go with class A, or I'll do one thing, Control Z. Let it be here, and I create a new Python file, test 10. So class A, I can create a method. So let me create a class level method. How to create class level method? We saw that last class. So first is, we need to use the decorator at the rate class method. Say I name it as def, and name it as method underscore capital A. So we know that it is from class, and if it is a class method, it should take the argument CLS, and here I can say print class level or I'll simply go, okay, a class method, okay, and now I'll create one more class B. Again here I'll create a method, class method def m of b, sorry, m, why is it m underscore b, capital B, and again I'll put class, and then I'll print b class method. Okay, so we are good here. Now I will inherit A in class B. So what is the reason why I'm inheriting? Because I want to access this method also, because I want class B to have this method too. So how can I do? So B dot, I can say m underscore A. Similarly B dot, I can call m underscore B. Right, let me run this. So it is printing both A class method and B class method, but I accessed both the classes, so both the methods using the name of class B, right? This is the sample for calling the methods in inheritance. Now I'll add one more. What am I going to do? At the rate, okay, I don't want to say at the rate. Let me create one method, say addition. Okay, so let's take A comma B, and then it returns A plus B. And here I'll create a method def subtraction. Self A comma B returns A minus B. But these are what methods? These are instance methods. If it is instance method, you have to create object. So let me create obj A is equal to A of obj B is equal to B of. In fact, I don't need to create an object for A, because here I'm going to cover only how to access the parent class instance method using the child class object. Okay, so obj B dot, you can see that addition is also displayed 10 comma 20, and obj B dot subtraction is also displayed. I'll go with 20 comma 30. Okay, I'll print both. Because it is returning values, so I have to print them on the screen. Run this. 30 and minus 10, the reason is here A is bigger and A is smaller and B is bigger. Okay, I have changed it. Right, so 30 and then 10. Why is it saying A class method? Okay, this is because of it. Now using the child class object, I am calling the parent class instance method. You got it? All right. So what have we covered so far in this inheritance? I'll go back here. First, we understood why do we need inheritance. Why do we need? To reduce the number of lines and improve the reusability. And then different types of inheritance we covered. One is, first we started with single inheritance, and then we covered what is multi-level inheritance, and then we covered hierarchical inheritance, and very important inheritance is multiple inheritance, and then we covered hybrid inheritance. And then we saw how can we use class variables when we do inheritance, and then how the class variables are inherited in inheritance, and then we saw how class level methods are inherited when we do inheritance, and also we saw instance variable inheritance, and also we covered instance method inheritance. In this, the tricky part is instance variable inheritance, right? If the instance variables are initialized in the constructor, then how can we handle it? That we covered to handle. There are two ways. Either we can use parent class dot the inheritance constructor method, and then we need to use the keyword called self. If not, we need to use the keyword called super. If by using the keyword super, we can again call the constructor of the super class, and we don't need to pass self as an argument. But the challenge or the trick is, when you use super, it will always take the first in the order, right? If there are multiple classes are inherited, then the first in the order will be taken as super class. Okay, so this is what we have covered, team. With this, we are coming to the conclusion of this session. Practice well, and then if you have any questions in inheritance, put it in the comments. I'll be happy to answer them. Until we see the next session, take care and keep learning. Bye.